Hello, this is Majid from Baghdad. Here's the thing. The power outage here in Baghdad may last for 12 hours a day. Can you believe it? 12 hours a day. And we are living in the hottest spot on planet Earth. Today, the temperature reaches more than 50 degrees Celsius, about 122 Fahrenheit. I do own a solar panel, but I found it useless because the efficiency decayed dramatically because of a very hot weather and a very low amount of ultraviolet radiation. So I bought this wind turbine from Alibaba.com and been shipped to me by UPS. The manufacturer claims that such wind turbine is capable to produce 400 watts. The length of each blade is 60 centimeters and from the tip to the center of the hub is 62 centimeters. Here are some accessories with the turbine. You can see a few Allen keys and the instruction manual, nose cone, and I found few rusty spots on the slip rings, which is responsible to transfer the power from fixed part to movable parts. So I used a very fine sandpaper to get rid of them. I tried to connect the turbine charger controller directly to my 24 battery bank, but unfortunately contact happened with a big spark, of course, between the positive side of the battery to one of the three-phase wires output. Then a brake applied to my wind turbine shaft that I couldn't rotate by my hand. Then I knew that something wrong happened. Since we have no market of wind turbine accessories, I had to tear down the controller and here what I found. 3 transistors were totally fried, as you can see, and underneath them there were 6 diodes which are responsible for rectification of 3-phase. They are planar mounted disc type. I soldered these wires to test the circuit later and should be laid on heatsink, which is the cover of the controller. Here are 3-phase wires, which are about 2.5 square millimeters cross section, connected directly to the drain part of the 3 MOSFETs in the other circuit. These are 2 wires. They are so thin because the control circuit doesn't need heavy current. Their cross section is about 1 square millimeters each one. There are 3 unlabeled LEDs. One of them is red. I've concluded that it will be an indication of a full charge. The other is for on power, while I do not know what the function of the middle one. I think I smashed this diode, which is planar mounted, during the teardown because it was inside a very hard epoxy. So I have soldered a regular diode, as we should see later. I am thinking of replacing these diodes with the car alternator set of diodes, 3-phase diode. There are 6 diodes, a very heavy current diodes, and should be attached to the circuit. Here's the plus polarity and here is the negative polarity, and they are capable to withstand a tremendous amount of current and heat. Here is the diode which is broken. The polarity of the diode is obvious. The cathode and the anode, they are connected to one of the three-phase wires and connected to a polar capacitor, smoothing capacitor, to the rest of the circuit. And here's the diode, the regular diode. I've soldered the place of the broken one. Now I'm trying to test the electronic circuit. So I used my dual power supply for 12 volt version and connected them to the control circuit. I have set the power supply to 12 volts, and whenever I increase it to about 14 to 15 volt, you could notice that the red LED is lit, indicating that the batteries are fully charged and it will apply a brake effect on the wind turbine. So switch off the power supply and pull out the LED and increase it to about 24 volts. Then connect the circuit again and increasing the voltage to about 29.5 volt. We can notice that the LED is lit again. So nothing is wrong with the control circuit. You can notice that there is still remains of an epoxy on the board. I couldn't pull it out. You can notice also that when I decrease the voltage to about 24 volts, the red LED goes off, indicating that the control circuit operates on both 24 or 12 volt versions. And now back to my power supply. I use the second half to simulate the generation, the voltage generation, the power generated from the wind turbine by connecting them with a common wire, both supplies. As you can see here, I wanted to discover the function of the middle green LED. So I injected a voltage for about 10 volts to the one of the three-phase wires, and you can see it is lit. So the middle LED is an indicator for a rotation of the wind turbine. Here is the actual circuit of the controller. There are three FETs. All drains are connected to the end of each winding of the turbine, as you can see here, and all sources are connected in common to the ground, I mean to the negative pole of the battery. All three gates are connected to control circuit, so that I have noticed that whenever the red LED is lit, a positive voltage is applied to the gates. So the FETs all are N-channel. In this case, each FET will be on, drawing a heavy current to the ground, causing a heavy load, which in turn causes a brake effect. The main drawback of the system is the grip of the wind turbine mast or pole. You can see that the bolt won't sit properly on the mouth of the hole, causing it very hard to screw and unscrew, and wouldn't secure it properly. A few days ago, there were not even a breeze of wind to spin my turbine. You see, we are unlucky even in environmental issue. Till then, there will be a next video. Thanks for watching. Best regards from Baghdad.